inrush current limiter is a device designed to extend the life of incandescent lamps. This device is typically a small, cylindrical component installed within a standard medium-base Edison lamp socket positioned behind the lamp. At its core lies a negative temperature coefficient, abbreviated NTC thermistor. This thermistor exhibits a unique characteristic: its resistance decreases as its temperature rises. When the lamp is initially switched on, the NTC thermistor is relatively cool, and its resistance is high. This high resistance serves to limit the initial surge of current that flows through the lamp filament. By controlling this inrush current, the stress on the filament is significantly reduced, leading to an extension of the lamp's overall lifespan. As the lamp operates and generates heat, the NTC thermistor responds by decreasing its resistance. This reduction in resistance allows more current to flow through the filament, enabling the lamp to operate at its design brightness. The benefits of using inrush current limiters are most pronounced in scenarios where incandescent lamps are frequently switched on and off, or when they are exposed to voltage surges. These conditions can accelerate filament degradation, and the inrush current limiter mitigates these effects. Here are other approaches can extend the life of lamps. Firstly, verify the voltage at the socket. It is critical to ensure that the voltage supplied to the lamp socket does not exceed the lamp's rated voltage. Excessively high voltage can lead to premature lamp failure. Secondly, use high-quality lamps. Investing in lamps from reputable manufacturers is advisable. These manufacturers typically adhere to stringent quality control standards and utilize superior materials, contributing to enhanced lamp longevity. Thirdly, avoid using dimmers if possible. Dimmers can introduce voltage fluctuations that can negatively impact the lifespan of lamps. These fluctuations can stress the filament and lead to premature burnout. Fourthly, install a surge protector. A surge protector serves as a safeguard against voltage spikes, which can inflict damage on lamps. By diverting or suppressing these surges, the surge protector helps to protect the lamps from potential damage. Fifthly, consider using light-emitting diode, abbreviated LED, bulbs. LED bulbs offer a significantly longer lifespan compared to incandescent bulbs. They are also less susceptible to voltage fluctuations, making them a more robust choice for applications where voltage stability may be a concern. Half-waving the lamps involves introducing a diode into the circuit to achieve half-wave rectification. Half-wave rectification means that current flows through the lamp only during one half of the alternating current, abbreviated AC, cycle. While this approach may reduce the average power consumption of the lamps, it does not effectively address the issue of inrush current or reduce the stress on the filaments. Therefore, it is not a recommended method for significantly extending the lifespan of incandescent lamps. Now, diving into the technical aspects of inrush current limiters, let's consider the specifications and factors that determine their suitability for different lighting applications. Firstly, the resistance of the NTC thermistor at room temperature is a critical parameter. This resistance value determines the extent to which the inrush current is limited when the lamp is initially switched on. A higher resistance provides greater inrush current limiting, but it can also affect the lamp's initial brightness. Secondly, the thermal time constant of the NTC thermistor is another important factor. The thermal time constant represents the time it takes for the thermistor to heat up and reduce its resistance. A shorter thermal time constant allows the lamp to reach its full brightness more quickly. Thirdly, the maximum current rating of the inrush current limiter must be sufficient to handle the normal operating current of the lamp. Exceeding the maximum current rating can lead to overheating and failure of the thermistor. Fourthly, the voltage rating of the inrush current limiter must be compatible with the supply voltage. Using an inrush current limiter with an insufficient voltage rating can result in damage to the device. When selecting an inrush current limiter, it is essential to consider the specific characteristics of the incandescent lamp being used. These characteristics include the lamp's wattage, voltage, and inrush current. Matching the inrush current limiter to the lamp's specifications ensures optimal performance and protection. Furthermore, it is advisable to choose inrush current limiters from reputable manufacturers. These manufacturers typically provide detailed specifications and performance data for their products, allowing for informed selection. Installing an inrush current limiter is a straightforward process. The device is simply inserted into the lamp socket behind the lamp. It is important to ensure that the inrush current limiter is properly seated in the socket to ensure good electrical contact. Additionally, it is recommended to periodically inspect the inrush current limiters to ensure that they are in good condition. Any signs of damage or overheating should be addressed promptly. Now, regarding the issue of lamps constantly burning out, several factors could be contributing to the problem. Firstly, voltage fluctuations are a common cause of premature lamp failure. Voltage fluctuations can stress the lamp filament and lead to its eventual burnout. Secondly, excessive vibration can also shorten the lifespan of lamps. Vibration can weaken the filament and cause it to break. Thirdly, poor ventilation can lead to overheating, which can also reduce the lifespan of lamps. Overheating can cause the filament to oxidize and become brittle. Fourthly, using lamps with an incorrect voltage rating can also lead to premature failure. Using a lamp with a voltage rating that is too low for the supply voltage can cause the lamp to overheat and burn out quickly. Fifthly, loose electrical connections can cause arcing, which can damage the lamp and shorten its lifespan. Now, to address the issue of lamps constantly burning out, consider the following steps. Firstly, measure the voltage at the lamp socket to ensure that it is within the acceptable range. A voltmeter can be used to measure the voltage accurately. Secondly, check for any sources of vibration that may be affecting the lamps. Vibration damping measures can be implemented to reduce the impact of vibration. Thirdly, ensure that the lamps have adequate ventilation. Improving ventilation can help to prevent overheating. Fourthly, verify that the lamps have the correct voltage rating for the supply voltage. Using lamps with the appropriate voltage rating is essential for ensuring their longevity. Fifthly, inspect the electrical connections at the lamp socket to ensure that they are tight and secure. Loose connections should be tightened to prevent arcing. Regarding the use of 130 volts lamps, these lamps are designed to withstand higher voltage fluctuations than standard 120 volts lamps. However, they may not be readily available in all locations. If 130 volts lamps are not available, consider using high-quality 120 volts lamps from reputable manufacturers. These lamps are typically designed to be more durable and resistant to voltage fluctuations. Additionally, using LED bulbs is a highly effective way to address the issue of lamps constantly burning out. LED bulbs have a much longer lifespan than incandescent lamps and are less susceptible to voltage fluctuations. They are also more energy efficient, which can lead to significant cost savings over time. When choosing LED bulbs, it is important to select bulbs with the appropriate brightness and color temperature for the application. LED bulbs are available in a wide range of brightness levels and color temperatures, allowing for customization to suit specific lighting needs. In addition to the measures mentioned above, consider installing a whole-house surge protector. A whole-house surge protector can protect all of the electrical appliances and devices in a home from voltage spikes, including the lighting system. This can provide an extra layer of protection and help to prevent premature lamp failure. Also, consider using a power conditioner. A power conditioner is a device that regulates the voltage supply to electrical appliances and devices. It can help to smooth out voltage fluctuations and provide a more stable voltage supply, which can extend the lifespan of lamps. Now let's discuss the technical details of surge protectors. Surge protectors work by diverting excess voltage away from sensitive electronic equipment. They typically contain a metal oxide varistor, abbreviated MOV, which is a voltage-dependent resistor. When the voltage exceeds a certain threshold, the MOV resistance decreases dramatically, allowing the excess voltage to flow to ground. Surge protectors are rated in terms of their surge current capacity, which is the maximum amount of current that they can safely divert. A higher surge current capacity provides greater protection against voltage spikes. It is important to select a surge protector with a surge current capacity that is appropriate for the application. Surge protectors also have a voltage protection rating, which is the maximum voltage that will be allowed to pass through to the protected equipment. A lower voltage protection rating provides greater protection. It is important to select a surge protector with a voltage protection rating that is compatible with the protected equipment. Surge protectors are typically installed at the service entrance of a building or at individual outlets. Whole house surge protectors are installed at the service entrance and protect all of the electrical circuits in the building. Outlet surge protectors are installed at individual outlets and protect only the equipment plugged into that outlet. It is recommended to use a combination of whole house and outlet surge protectors for comprehensive surge protection. Now let's discuss the technical details of power conditioners. Power conditioners work by regulating the voltage supplied to electrical appliances and devices. They typically contain a transformer and electronic circuitry that maintain a stable output voltage regardless of fluctuations in the input voltage. Power conditioners are rated in terms of their voltage regulation accuracy, which is the percentage of deviation from the nominal output voltage. A lower voltage regulation accuracy indicates better performance. It is important to select a power conditioner with a voltage regulation accuracy that is appropriate for the application. Power conditioners also have a power rating, which is the maximum amount of power that they can deliver. It is important to select a power conditioner with a power rating that is sufficient to handle the load of the connected equipment. Power conditioners are typically used to protect sensitive electronic equipment such as computers, audio equipment, and video equipment. They can also be used to protect lighting systems from voltage fluctuations. In summary, extending the life of incandescent lamps requires a multifaceted approach. This includes using inrush current limiters, verifying the voltage at the socket, using high-quality lamps, avoiding dimmers, installing a surge protector, and considering LED bulbs. By implementing these measures, the lifespan of incandescent lamps can be significantly extended, reducing the frequency of replacements and saving energy. In addition to the specific tips for extending lamp life, it's helpful to understand the general principles of electrical circuits and how they affect lamp performance. Firstly, Ohm's law states that voltage equals current times resistance. This fundamental law governs the relationship between these three electrical quantities. A higher voltage will result in a higher current for a given resistance. Secondly, power is the rate at which energy is transferred. In an electrical circuit, power is equal to voltage times current. A higher voltage or a higher current will result in a higher power consumption. Thirdly, resistance is the opposition to the flow of current. A higher resistance will result in a lower current for a given voltage. The resistance of a lamp filament increases as its temperature increases. Fourthly, alternating current is electrical current that periodically reverses direction. The frequency of AC power in most of the United States is 60 Hz, which means that the current reverses direction 60 times per second. Fifthly, direct current is electrical current that flows in one direction only. Batteries and solar panels produce direct current. Understanding these basic principles can help in troubleshooting lighting problems and in selecting the appropriate lamps and lighting components. For example, if a lamp is constantly burning out, it could be due to a voltage that is too high. Measuring the voltage at the socket can help to confirm this. Similarly, if a lamp is not as bright as it should be, it could be due to a voltage that is too low or a resistance that is too high. Measuring the voltage and resistance can help to identify the cause of the problem. When working with electrical circuits, it is important to take safety precautions. Firstly, always disconnect the power before working on any electrical equipment. Secondly, use insulated tools to avoid electric shock. Thirdly, wear safety glasses to protect your eyes. Fourthly, follow all applicable electrical codes and regulations. Working with electricity can be dangerous, so it is important to take precautions to protect yourself and others. In addition to the information provided, it may be helpful to consult with a qualified electrician for assistance with lighting problems. An electrician can assess the situation, identify the cause of the problem, and recommend the appropriate solutions. They can also perform electrical work safely and in compliance with all applicable codes and regulations. Finally, remember that energy-efficient lighting can save money and reduce environmental impact. Consider using LED bulbs or other energy-efficient lighting technologies to reduce energy consumption and lower electricity bills. Energy-efficient lighting also helps to reduce greenhouse gas emissions, contributing to a more sustainable future. In conclusion, by implementing a combination of the measures discussed, one can significantly extend the lifespan of incandescent lamps, reduce the frequency of replacements, save energy, and improve the overall performance of lighting systems.